Today I will be demonstrating the construction of a phylogenetic tree by using a rooted tree structure with the creation of the subclass Mammalia, serving as its root to classify 8 different mammals. So we will begin by asking the question, how do they give birth? First of all, most people recognize that mammals give live birth. However, there are a select few mammal species that actually lay eggs, and these species are all in the order Monotremata. The direct evolution from our root to the order Monotremata is an example of anagenesis. This primitive and direct evolution into an egg-laying mammal suggests that this type of mammal may have been the earliest to evolve as well, making Monotrematas the outgroup. Now, as for mammals that give live birth, there are a couple ways that mammals have evolved to do this. This is an example of cladogenesis, where our tree will begin to branch off into several clades, each sharing a common ancestor before evolving into something new. For the clade of mammals that exhibit live birth, we ask the question, how viable are the newborn offspring? Mammals that give live birth are either Metatheria or Theria. Metatheria are marsupials such as opossums who give birth to underdeveloped live young who leave the womb only to crawl into a pouch where they will continue to develop for some time before they are able to survive outside the pouch. Theria, on the other hand, have offspring that are completely developed and able to survive outside the womb at birth. Theria represent the vast majority of all mammals, so to further classify our remaining mammals, we are asked the question, what do these mammals eat? This branching point, as well as any branching points before and after it, is an internal node that represents the common ancestors of those descendants. Now, mammals can be simply classified by herbivores who have evolved to sustain themselves on only plant materials, and animals that have evolved to be able to continue consuming meat. The only 2 mammals on our list that are classified as herbivores are rabbits and manatees. Now, these 2 mammals are obviously pretty genetically different from one another, so it can be assumed that they have a high number of OTUs, or differences in DNA sequences. This is represented by the length of the lines that separate them. The longer the line, the more OTUs the set of animals have, the more genetically different they are from one another. Now, left on our list, we have 4 different mammals that can consume meat. Mice and rats are pretty genetically similar to one another, so they will have a very short segment separating them from their connecting node because they have a much lower OTU count. And though humans and chimpanzees do share a common ancestor, visibly you can tell these 2 mammals are not so genetically similar, so they will have a higher OTU than the mice and rats. What links these 2 sets of animals is how they are capable of walking. Mice and rats are both obligatory quadrupeds who walk on all 4 legs all of the time, while humans and chimpanzees both have the capabilities to be bipedal. With this reasoning, we have filled out our phylogenetic tree. Thanks for watching!